Math 1332, Chapter 2, Set Theory, Section 2.2, Subsets and Set Operations, Video 5, Proper Subsets, Venn Diagrams. In the previous video, we defined what it meant for one set to be a subset of another. Set A is a subset of set B if everything inside of A is also inside of B, or if every element of A is also an element of B. But what does it mean to be a proper subset? Set A is a proper subset of set B, written symbolically as A is a proper subset of B. And I want you to notice that this symbolic representation looks almost just like the symbol for subset. But do you see the only difference? When we said A was a subset of B, the symbol looked like this. But do you see the difference? The symbol for proper subset does not have that extra straight line, whereas this one does. And it seems insignificant, but I'll show you an easy way in a moment to remember the difference between the two. But first, let's define it. Set A is a proper subset of set B, written symbolically as A is a proper subset of B if two things. Number one, A is a subset of B, which still means that everything in A belongs to B. But there's a second condition, and A is not equal to B. That's what makes it a proper subset. It is actually smaller in the sense that B contains things that A doesn't. In other words, you could say that A is a subset of B, proper subset of B means two things. Number one, if X is an element of A, then X is an element of B, which is saying that everything in A also belongs to B. But they're not equal, which means that B contains something that A does not. So we can say there exists some X an element of B such that X is not an element of A. So B is bigger because it has something that A doesn't. So it's still a subset, it's just not equal to the larger set. For example, this looks like the same setup as in the previous video, but there's a subtle difference. Our universal set is still 1 through 10. Set A still contains 2, 4, and 8. Had a yawn there. Set B still contains 2, 4, 6, 8, and 10. But set C now contains 2, 4, and 8. In the previous video, it also contained the number 1. So who's a subset of whom? Well, A is a subset of B. Who's a proper subset? Is A a proper subset of B? Well, if you're going to say it is, then you have to check two things. Does everything in A belong to B? Just check each element of A. 2, do you belong to B? Yes. 4, do you belong to B? Yes. 8, do you belong to B? Yes. Condition number 1 is met. It is a subset. But are they not equal? Meaning, is there something in B that's not in A? This is easy to check. You go to B and see if anybody is not checked off. Hey B, do you contain anyone that does not belong to A? The 6 and the 10. Neither one are in A. Okay, you're a proper subset. Who else is a proper subset of whom? Well, all of these are proper subsets of the universe. A is a proper subset of the universe, as is B, as is C. And C is a proper subset of B because everything in C is in B. Well, wait a minute, doesn't C match A? It does. These are the same sets. Now, we could say that A is a subset of C because we could go to every element of A and ask it, do you belong to C? 2, are you in C? Yes. 4, are you in C? Yes. 8, are you in C? Yes. So we could say that A is a subset of C, but we can't say it's a proper subset for two reasons. Number one, they're equal. The sets are equal, and being a proper subset says, nope, it can't be. Or the second criteria is not satisfied because after we've checked off everybody that matches, we go to the quote-unquote larger set and say, okay, do you have anybody who's not in A? Nope, all of my stuff is in A because I was equal to A and I can't be. So I can say that A is a subset of B, but I can't say that it's a proper subset, written by putting a slash through the proper subset symbol. Is A a proper subset of itself? Well, it's clearly a subset of itself. That was one of the observations that we made at the end of the last video, or during the last video. But being a proper subset means that you can't be equal, and I think it's pretty obvious that A is equal to itself. So no set is a proper subset of itself. Is the empty set a proper subset of these guys? We know it's a subset, because in the last video we said the empty set was a subset of every set. But is the empty set a proper subset of A? Well, let's check it out. Hello, empty set. We're going to see if all of your elements are in A. Done. Because there were no elements to check. Now we go to the larger set and say, is there anybody who wasn't accounted for yet? Yeah, everybody, because the empty set was empty. The empty set is a proper subset of every set except itself. In other words, the empty set is not a proper subset of itself, because the definition of proper subset says you can't be equal, and these are. So proper subset is just like subset with one extra condition. The larger set is not the same as the smaller set, because the larger set contains extra elements. Now, how do you draw a Venn diagram for subsets and proper subsets? In general, to draw a Venn diagram to show that one set is a subset or a proper subset of the other, you just draw one circle inside of another. If I want to show that circle A, that set A is a subset of set B, I have to draw set A inside of set B. That shows subset. One is inside the other. A is a subset of B. But does it show proper subset? Well, in order to be a proper subset, there has to be an element in the larger set that does not belong to the smaller set. So if we wanted to show that A was a proper subset of B by listing its elements in the Venn diagram, let's list all the elements in the Venn diagram. A contains 2, 4, and 8, so let's go ahead and put those in there. B contains 2, 4, 6, 8, and 10. The 2, 4, and the 8 are already inside of B, but the 6 and 10 are not, so I need to put them there. If this were a fried egg, that would be the white. The middle would be the yolk. And all the odd numbers live outside of B, 1, 3, 5, 7, and 9. So how do you show that a set is a subset in a Venn diagram? You draw one circle inside of another. How do you show it's a proper subset? You have to go a little bit deeper and literally illustrate that there is an element in the bigger set that is not in the smaller. In this case, there's 2 of them. It's the presence of these elements that indicate that A is a proper subset of B, because B contains things that A doesn't. If there were no numbers out here, if the 6 and the 10 weren't there, and this was the whole picture, we could not say that A is a proper subset of B, because A and B would be equal. They contain the same numbers, 2, 4, and 8. It's going to bother me to not have the 6 and the 10 there. So just remember, subset means one is inside of the other. Proper subset says the same thing, but also says the bigger set is actually bigger in the sense that it contains elements that the smaller set doesn't.